This lesson. In today's lesson, we'll be considering equations of modular arithmetic. So let's take a look at this question. Prior to this class, we had already done some operations and simplification under modular arithmetic, such as addition, subtraction, multiplication. So in today, we want to take a look at how to obtain an unknown under modulo arithmetic. Let's consider these two questions. We have the first one, which says 3x equals 5 mod 7. Then the second one says 2x plus 3 equals 1 mod 6. So let's take a look at the first one. 3x equals 5 mod 7. So the techniques we normally apply when resolving problem under arithmetic, modular arithmetic, is that we actually need a number that when divided by 7, it will give us a remainder of 5. An immediate number which when divided by 7 will give us a remainder of 5. So that's simply like adding 5 plus 12, right? 5 plus 7. So 5 plus 7 will actually give us 12. So that will be 3x equals 12. When you go ahead and divide both sides by 3, you obtain a value of 4. So your x is actually 4 mod 7. That answers the question. That's the easiest way to quickly do this. You can equally test the numbers, okay, by using inspection method, by subjecting x to some certain value starting from 1 to test run it, which one is going to give us the right answer. But instead of doing the inspection method, you can use this induction method by just adding up the value 5 plus 7. So far 12 is divisible by 3. So the answer surely will be 4 mod 7. So again, the second question, which says 2x plus 3 equals 1 mod 6. So this 3 here is like a period. You assume it's a period in this case now. Okay, it's a period in this case. So let's take a look at the function of this 3 at the end of the day. Okay, the same process. You can add 1 plus 6, that will give us 7. Then when you move 3 to the other side of the equation, you have 7 minus 3, which will give you 4. You end up by dividing both sides by what? By 2. Or you divide both sides by 2 here. You have what? You have x to be 2 mod 6. So this answers the question. So now the reason why this 3 is there is that, look at this. Since the period of the equation is 3, the period of this equation is actually this 3. So you check, if I add this 3 to this 2, will it be up to or equal to 6? It will not. So that means we can prefer another answer, which is what? Another solutions to this question, which is 2 plus 3 mod 6, and that will give us 5 mod 6. It's still correct. Now, to justify this our answer, we can use this alternate method. To solve another alternate method to solve this question again. So in this case, what do? You try to eliminate these 3 by moving to the other side of the equation, but to only be used with this one, not together with 6. Just leave mod 6 out of it. So you can have 2x plus 3 minus 3, which will be equal to 1 minus 3 mod 6. So if you do that, you obtain 2x equals minus 2 mod 6. So this minus 2 we have here is a negative value. We can transform it into a positive, because negative under modulo or modular arithmetic signifies anticlockwise movement. So we can actually make it positive. So how do you do that? You recall when we're doing simplification of moduli under subtraction, under negative values. So here we have -2. So -2 can be written as -6 multiplied by 1 plus 4. Then how do you get this -6? What is it doing here? This -6 is coming from the modulo. Okay, just pick the modulo and put a negative value there. Okay, multiply by 1. Why do I multiply by 1? Because I know that if I take 6 and multiply by 1, it will give me 6, which is actually what? Greater than 2. Greater than this 2. You understand? 6 multiplied by 1 will give me 6, and which is greater than 2. So there is no need of me using a higher number here. So I can just stick with 1. Then in order to balance the equation, I have to add 4. Because -6 multiplied by 1 will give me -6, then plus 4 will give me -2 again. So that answers balances the equation. So you see this 4 that you have to add to balance the equation now become the path to the solution. So it means your answer can be this -2 mod 6 can be written as 4 mod 6 now, as this 4 mod 6. So you now have 2x equals 4 mod 6. Okay, then you apply the same thing that you did before. You understand? So immediate number when divided by 6 has a remainder of 4 is 10. Okay, immediate number that if you divide it by by 6, you have a remainder of what? When divided by 6, you have a remainder of 4. Okay, that value is what? Is 10. So you can equally say just 4 plus 6, that will give you 10 also. So 2x equals 10. Or you divide both sides by 2, you obtain your x equals 5 mod 6. You can see the reason why 5 mod 6 is part of the answer. So this is it. This is one of it, and the other way around is the one we did before. So you can go back to that right and still look at it again if you don't understand it better. So now, in order to prove our second answer here, we can recall this same equation that we have here. We can bring it back here, which is what? 2x equals 4 mod 6. So now since this 4 is divisible by 2, there's no need of involving 6. Just divide it by 2. Okay. So when you divide it by 2, you have your x equals 2 mod 6. So these are the two possible answers that can be used as the result or solutions to this particular given question. I hope this is well understood. Okay, let's proceed. So this is the third question. So this third question is coming as an exponential, okay, a modulo arithmetic involving exponential equation. Okay, sometimes it could be quadratic, it could be any form, but this is exponential equation or modular arithmetic involving exponential equation. Something like this, we call it interconnected question. Okay, so how do you do this? The first thing to do is that check this your left hand side is 3 raised to power x equal to 2 mod 5. 3 raised to power x is not 3x, so you have to be very careful. So you can use trial and error method, which is known as inspection method, by subjecting x to 1, 2, 3 and try to find the possible values that will equally give you the right answer. And you can equally do it like this, that okay, 3x which is equal to 2 plus 5. Okay, that was the first thing. That will give you 7. This 7 is not a perfect square, it's not a perfect cube. So you can't subject it to a base of 3. So you can't do that. So you have to what? Keep on adding 5. When you add 5 to this side again, you have what? 10. So that will give you 12. The same thing, 12 cannot work out for us because 12 cannot be subjected to a base of what? 3. So you can't use that. Again, you add another 5 because 5 is our movement. So that will give you 17. And 17 again cannot be subjected to a base of what? Of 3. That's converting it to indices. It's not possible. So again, you add another what? Another 5. So that will give us 20. So which will give you what? 22. So this 22 is also the same thing. So it can't work out for us. So add another 5 till when you get the right value. Now look at it. This is the what? 27. This is 27. And this 27 now is the immediate possible number to be used. Okay. So you can now go ahead and transform 27 into what? Base of what? Base of 3. That's to transform into what? Indices. So that's it. You have 3 raised to power x equals what? Equals 3 raised to power 3. So when the bases are equal, definitely the powers are what? Are equal. That's the law of what? Of indices. So you have what? 3 raised to power x equals to 3 raised to power 3. Therefore, your x equals what? Your x equals 3. So it means 3 is the what? Is the possible, the first or the lowest possible number that can work out what we want. Okay. So that answers the question. I hope this is well understood. In case you see something like this in future, this is the method you can easily use to find a result to your problem. Okay, now let's take a look at some other part of this video. So this question is talking about a modular table, or you call it modulo table. So in this case, you'll be having fill the empty space in mode 4. Okay, you are given a table of this form, and you are meant to fill these spaces. So under this table, you could have multiplication here, subtraction here, or addition here. But in this case, now I have subtraction. The operator here is what? Subtraction. And that is what I used to what? To solve those ones here. Those ones here. But in this case now, we're meant to fill the other spaces, okay, using this operator. This one is similar to a binary operation table. So now let's take a look at so we are going to assume that this column, or this column is our first number. So while this row is our first our second number. So let's take a look at example 1. In this example 1, you said we should resolve 1 operation 2 mode 4. Okay, and the operation is not negative. So 1 minus 2 will give you what? Minus 1 mode 4. So you have minus 1 mode 4. Just convert it to positive and see what will happen. Again, your minus 1 can be subjected into what? Can be subjected into minus 4 multiplied by 1 plus 3. I've already done this before. So that's going to be what? 3 mode 4. So that means 1 operation 2 mode 4 is something as 3 mode 4. So your answer is 3. You just go to your table there and put your 3, because 1 operation 3 is actually 1 operation. 1 operation 2 is actually what? This 1 here, because the first number. You go like this till when you meet 2. So that is why we position our 3 there. Now let's consider another example. The other example we have here is 1 operation what? 3. So that means I want to fill this space here. So if you do that, you have minus 2 mode 4. And minus 2 can also be transformed into this. So in a nutshell, I have 2 mode what? Mode 4. Remember, we always pick this. You understand? Don't forget that the reason why we choose minus 4 is because it's what? Mode 4. So, and it's negative here. So you have to be negative 4 multiplied by 1. You don't need to use 2 because 4 is already greater than what? Than 2. So no need of using higher number here. Okay, so I need to balance the equation. We have 2. You have to add 2. So when you add 2, you have what? You have minus 2 back. So these 2 you are adding transform your expression into what? Into 2 mode 4. So the answer is 2. You can go to the box there and position your 2 at the right place. So following this trend, you can obtain other ones like this. Because if I say 0 minus 1 is going to give minus 1, which is similar to this. So that is why the answer is still 3 there. Again, if I say 0 minus 2, it's going to give minus 2, which is also similar to this. And the answer will also be what? 2 there. Okay. Likewise, this 0 minus 3 is going to give me minus 3. And when you work it out very well using this same method, it will give you 1. And lastly, I have 2 minus 3, that's 2 operation 3, which is this space here. That's going to give me minus 1, which is also similar to this one. So the answer will also be what? Will also be 3. So I hope this is well understood. It's going to give you, if it's giving you a problem while going through it, you can always pause the video or you repeat the video to get the understanding. Okay, these are questions for us to use as an evaluation questions. So it says solve the following questions. Number 1, you are meant to resolve this under what? Mode 6. You can see. So there are 5 questions here. They have to do them under what? Mode 6. So then you only have this challenging question. This one you need to just use your, it's just the same thing, but you need to critically transform it into mathematical statement as an applied question. Okay, so you have another one here, and you have another one here. Okay, if you look at this one, you can see in this case now I have 3 plus 4 equals 7 mode 8, and you have that. Okay, so that is how the question is. Then you have this here. Look at this question here, this quadratic question. Try as much as possible to do them. It's very easy. You can make research and get it right. And this is the kind of one that I just did before. So you can equally do this one in mode 5, in mode 6, and in mode 9 and get the right answer. So also I have the last question here, which is modular table. So you are meant to complete this. Don't forget the operator here is what? Is multiplication. Okay, we assume it's multiplication. And I'm going to take your column, this column here, which is first column here, to be your first number, while this side is going to be your second number. Okay, so you already know how to do that, right? So you do them individually to fill all the spaces. I hope this video has actually added to our knowledge. Thank you for being part of this class. See you in my next class.